Hi, I'm Hye-Young and I'm grateful to present to you our work, CollageVis, Rapid Previsualization Tool for Indie Filmmaking using Video Collages, on behalf of co-authors Dr. Suzuki from the University of Calgary and Dr. Yoonji Kim from Jungwon University. Previsualization, or previs, is prototyping various film scenes or shots before filming. This process is essential in film production for cinematographic experiments and effective collaboration. However, traditional previs methods like 2D storyboarding and 3D animation require substantial time, cost, and technical expertise. So, indie filmmakers with limited resources often struggle to create previs. To solve this, we propose CollageVis, which allows indie filmmakers to create previs by collecting short video clips and composing them as a video collage. This video on the left is an example previs we made replicating the Netflix TV series Squid Game on the right. Compared to traditional previs methods, storyboarding or 3D animations, video recording is already a familiar working method for filmmakers. Also, the final video collage is easy to understand, which is critical for effective communication among technical and non-technical staff. The CollageVis system has two user interfaces, CollageBoard and Virtual Stage. It mainly runs on a laptop, and the mobile is used as a supplementary tool for camera-related functions in each interface. The first interface, the CollageBoard, handles source collection and modification of video collage for simple static shots. Building on that, the second interface, the Virtual Stage, allows layout and camera exploration for complex shots. Now let's take a closer look at each interface. The CollageBoard takes videos as input and composes them on a board in real time. It also takes an image input and sets it as the backdrop. The input acting video can be a test shot of a real actor or a staff standing as an actor. Then the user can apply a name tag, color filter, and face swap filter to differentiate each character. The Virtual Stage supports further exploration in layout and camera movement design. Instead of an image backdrop, it simulates a more detailed shooting environment, such as different weather conditions and locations. For the location 3D data, the system supports both scanned and modeled data. In this virtual environment, the user can test the layout of various components like actors, staff, lighting gears, and multiple cameras. The system provides accompanying mobile application to navigate the virtual stage and control the virtual camera, which allows camera work exploration without technical proficiency in 3D software. Then, the system outputs a previs video and a floor plan video. Looking at prior work on 2D previs, many commercial tools and academic research try to speed up the sketching process. However, they still require drawing skills. On the other hand, some researchers developed AI systems that generate sketches from the user's story description. These works are extremely fast and convenient. However, they heavily rely on pre-existing image data and require prompt engineering efforts for the right image. As to the 3D previs, commercial tools offer infinite freedom for technical experimentation, but mastering them requires extensive learning of 3D digital content creation tools and game engines. Some researchers proposed VI previs with direct manipulation and a concept similar to ours, where the user assumes multiple roles. However, VR requires extra devices and unfamiliar working methods for filmmakers. Also, some researchers replaced complex character animation with physical mockups, and others developed 3D previs automation tools that convert script into 3D animations based on the data library. However, these works support limited character animations and lack expressiveness compared to videos with real actors. As we briefly look through, there are many promising previs tools in both industry and academia, and each holds intrinsic value. However, these tools are not actively used in Korean indie film scenes for various reasons. So we conducted formative interviews with 6 indie film directors to review these tools and to better understand the common practices and challenges of indie film previs. From the interview, we identified the difficulties of using existing previs tools and practical needs in indie filmmaking. For example, directors said making test videos is a more familiar and clear previs method than storyboarding, but more difficult to execute due to scheduling and financial issues. Also, directors said they rarely make 3D previs but always draw a floor plan for layout purposes. Based on these findings, we extracted the system design goals and designed system features. The devised CollageVis system has 4 key features: live video composition, character differentiation filters like tagging name, colorizing layers, and swapping faces, 2.5D spatial design where 2D video planes stand in a 3D environment, and virtual camera control with mobile. We demonstrated the system's capability by replicating 7 film scenes. Each example shows a different cinematic simulation, actors, environments, and camera work simulations. I will quickly go over the example scenes. This example shows a virtual casting with the face swap filter. And this one shows a crowd scene with body cloning. We recorded a few video clips and duplicated them about 50 times to compose the scene. Here we simulated different shooting environment with 3D data and weather particles. We also demonstrated various camera work. This scene shows a smooth camera transition like the dolly track effect in cinematography. This scene simulates the whip pan camera motion, quickly switching between dancers and a pianist. Finally, this subway scene demonstrates the shaking motion of a handheld camera. We also evaluated the system's usability with 6 indie film directors. Participants composed family dinner scenes using provided video clips for up to 60 minutes. After completing the task, participants answered 3 questionnaires: System Usability Scale Questionnaire to evaluate the system's general usability, NASA Task Load Index Questionnaire to assess the user's perceived workload, and a custom questionnaire comparing the CollageVis with their familiar previous practices like storyboarding, 3D animation, and test video. Finally, we asked participants to share their views on the system's value and limitations in the post-hoc interview. Looking at the questionnaire results, participants gave an average score of about 80 out of 100 on the system usability questionnaire, saying that taking a video is much easier than drawing or adding animation to 3D characters. They also reported a low perceived task load, about 16.8 out of 100. Finally, participants considered CollageVis a valuable alternative to their traditional previs methods, giving an average score of about 5.8 on a 7-point Likert scale in the custom questionnaire. Participants said it would be helpful to communicate with staff with various levels of technical proficiency. The custom questionnaire included the following 10 questions, ranging from general preference to specific feature evaluation, like floor plan and camera control. This stacked bar graph shows the average score for each question. As you can see here, participants gave high ratings to the collaboration, floor plan, and exploration-related questions, which means they thought the CollageVis system has benefits in communicating with staff, designing camera movement, and experimenting with their visions, compared to their accustomed previous methods. On the other hand, they gave relatively low ratings for the modification and the camera control-related questions, which means they found modifying the previous image and controlling a virtual camera challenging at times. When we look at each filmmaker's response, it's clear that they reacted differently to these 2 questions, which I will clarify later in this slide. Looking closely, participants thought video collages with floor plans would facilitate effective communication among film crews by clearly distinguishing characters and marking where each staff should stand in advance. However, 3D navigation and camera translation via mobile were only ideal for non-technical filmmakers. This becomes obvious when we look at each response. For non-technical filmmakers, highlighted in blue, thought the mobile app was intuitive. In contrast, 2 technical filmmakers, highlighted in orange, who are familiar with 3D software, thought the mobile was uncomfortable, saying that they just wanted to use a mouse for faster manipulation. Moreover, participants thought virtual rehearsal using videos and 3D data is beneficial for creative exploration compared to regular test video making. They thought they would have more time to experiment with everything, like designing the character's personality and exploring different framing, because they do not have to consume the crew's time and can work on previs anywhere, anytime. However, altering a portion of a video or perspective is not taken as easy as we hoped for. When we look closely at the easy modification question rating, the responses are split into two groups. 4 participants highlighted in blue strongly agreed that the system enabled rapid modification, whereas 2 participants highlighted in orange somewhat disagreed. This was because modifying some of the features like the character's face, shooting location, and camera framing was much easier than the storyboarding as we expected, but altering the character's hairstyle or perspective required them to reshoot another video clips, and some felt it was cumbersome. Our work needs the following improvement in the future. To name a few, we plan to support various input types like static pictures and dynamic annotation on the video for fast modification. We also plan to provide both mobile and mouse for virtual camera control. To recap, we conducted formative interviews to review existing previs tools with 6 indie filmmakers and understand their challenges in applying them in their filmmaking. Here we learned that they desire a less complicated tool with a tailored functionality somewhere between 2D storyboarding and 3D animation. We also learned that making test videos offer more opportunities to explore their vision because it's like a rehearsal for actual filming. But it is impractical considering the limited resources of low-budget film production. So we proposed CollageVis, an approach that leverages indie filmmakers' working method of making test videos and removing its temporal and physical constraints by allowing live composition of short video clips on a virtual stage. The CollageVis system further enhances the communicative aspects of test videos through actor differentiation filters and a flow plan. Then we demonstrated the system's capability in cinematic simulation of different actors, environments, and camera works by replicating 7 famous film scenes. Finally, we evaluated the system's usability with 6 indie filmmakers. Participants said the CollageVis was easy to use and valuable for collaboration, and all of them were willing to use it for their next films provided that it supported more flexibility in the input formats for easy modification and camera control methods according to their technical proficiency with 3D software. Our work suggests that combining physical rehearsal with digital enhancement could lower the technical barriers to previs making while maintaining a low cost. Thank you for your attention.